Hello and welcome to Investment Insight. Before we begin, make sure to subscribe and hit the like button. Now let's break down what's happening in the markets today in a clear and simple way. So I want you to imagine waking up on July 17, 2026. You brew your morning coffee, you pull out your phone to check your investment portfolio, and you just see an absolute bloodbath.
Oh, yeah, just a total sea of red.
Right. I mean, billions of dollars in American tech wealth just vanished before breakfast. The NASDAQ drops 1.4%, and the semiconductor index, it completely falls off a cliff.
Yeah, tumbling over 20% from its June high.
Exactly. And your first instinct, if you're holding those stocks, is to check the news for, like, a major geopolitical disaster or maybe a catastrophic jobs report.
But you wouldn't find either of those things. The actual catalyst for this massive market shock was, well, it was a software update halfway across the world.
Which is wild.
It really is.
Nah.
Specifically, it was the release of a new Chinese AI model called Kimi K3, and that was built by a company named Moonshot AI.
Which just feels entirely disproportionate, right? So today, our mission for this deep dive is to break apart this event. We need to figure out what a single foreign AI model actually means for U.S. tech stocks, for American dominance in the tech sector, and, for your personal portfolio.
Because as an American investor trying to navigate this economy, understanding the mechanics of this shift, it's basically mandatory now.
Right. So did a single line of code in China actually break the American tech monopoly?
Well, to unpack why the market reacted so violently, we have to isolate the reality of Kimi K3 from the sheer panic. Looking at the data, this model is a significant milestone. I mean, it boasts 2.8 trillion parameters and a 1 million token context window.
Okay, wait, let's pause and define those metrics real quick, because those numbers get thrown around a lot in tech media.
Yeah.
So think of a token as a piece of a word, right? Maybe 3 or 4 letters. So 1 million tokens translates to roughly 750,000 words.
That's a massive amount of text.
Right. That means you could upload a stack of thick financial reports, an entire corporate code base, or like several full novels into this AI, and it holds all of that information in its active short-term memory while you converse with it.
Exactly. And the crazy part is it handles that massive amount of information remarkably well. Recent analysis shows that in really rigorous evaluations, specifically tasks like building complex web interfaces or executing long-term software coding loops, K3 actually outperforms some of the absolute best U.S. models on the market.
Oh, wow. Like which ones?
Well, models including Anthropic's Fable 5 and OpenAI's GPT 5.6.
Okay, so my gut reaction here is to equate parameters to, like, horsepower in a car engine.
That's how most people see it, yeah.
Right, so 2.8 trillion parameters sounds like an overwhelming, unbeatable machine. A panic-selling investor sees that huge number and just assumes the United States has unequivocally lost the AI race. Tell me why I shouldn't just hit the sell button on my American tech ETFs right now.
Because treating parameters like a simple horsepower number entirely misunderstands how modern AI architecture functions.
Okay, how so?
Well, looking at the data, Kimi K3 is highly competitive, absolutely, but it isn't an outright defeat for U.S. tech. The underlying mechanism here is something called a mixture of experts model, or MOE for short.
MOE. Okay, I hear that term constantly in tech reports.
Yeah.
But how does that mechanism actually work in plain English?
Think about it this way. Instead of building one giant monolithic brain that fires all 2.8 trillion parameters for every single prompt you give it, Moonshot AI built a system that relies on a router.
A router. Like a Wi-Fi router.
Kind of, but more like a triage nurse.
Yeah.
Imagine walking into a massive medical center. You don't need the cardiologist, the neurologist, and the orthopedic surgeon to all look at your sprained ankle, right?
Right, that would be a huge waste of money and time.
Exactly. The triage nurse assesses your problem and routes you strictly to the bone specialist. The MOE router evaluates your text prompt and activates only the specific subnetworks the experts needed to answer it.
Oh, I see.
So while it technically houses 2.8 trillion parameters, it might only actively use, say, 150 billion of them for your specific question.
Okay, so that sounds incredibly efficient. But it also means it isn't just sheer brute force outsmarting American models across the board.
That is the core takeaway here. The data indicates K3 hasn't surpassed top U.S. models in every single category. Its real strength lies in very specific, complex tasks. What this model represents is proof that Chinese AI is maturing.
Right, it's not just a knockoff anymore.
Exactly. It is no longer just a cheap secondary alternative. It has evolved into a high-tier rival.
But, you know, whenever a rival suddenly closes a massive technological gap this quickly, accusations of intellectual property theft immediately follow.
Oh, absolutely.
And the narrative from several U.S. tech giants right now is that Moonshot AI relied on a process called distillation.
Right, and distillation is a really fascinating mechanism. It basically operates like a teacher-student dynamic.
How did it work?
Well, the accusation is that Chinese developers took the highly refined, brilliant outputs generated by top-tier American models, and they just fed those outputs directly into their own AI as training data.
So they basically used the American teacher model to fast-track the education of the Chinese student model.
Exactly, bypassing years of expensive trial and error.
But Moonshot AI vehemently denies this, right? They point to their own proprietary architecture, specifically something they call the Kimi delta attention mechanism. How does that counter the whole distillation argument?
Well, attention mechanisms are basically how AI models figure out which words in your prompt are the most important. Normally, when you ask an AI a follow-up question about a really long document, it has to recalculate the entire context of that document from scratch.
Which sounds like it takes a lot of processing power.
It does. But Moonshot's delta attention is designed to only calculate the delta, meaning just the changes or the new information. By caching the previous states, it saves immense amounts of computing power.
Ah, got it.
So Moonshot argues this highly innovative original architecture is the real secret behind their success, not copied U.S. data.
Look, as an investor, trying to play detective here is probably a trap. We have to look at this neutrally. I mean, it is entirely possible that they used American outputs to bootstrap their early models while simultaneously developing legitimate world-class internal innovations like delta attention.
Yeah, both things can exist at the exact same time.
Right. And focusing solely on the intellectual property debate kind of distracts from the actual reason the stock market panicked in July. Wall Street didn't wipe out 20% of the semiconductor index just because a Chinese AI wrote good software code.
No, they definitely did not. They panicked because of the price tag attached to it.
Yes, the pricing data is what really caught my eye. Looking at the analysis, the official cost to use Kimi K3 through their API is just $3 per 1 million input tokens and $15 per 1 million output tokens.
Which is just staggeringly cheap.
It drastically undercuts the premium pricing structures we see in the United States.
Right. And to understand the sheer terror that pricing model caused in boardrooms across Silicon Valley, we have to look at the massive capital expenditure cycle U.S. companies are currently trapped in.
Okay, let's visualize this for everyone listening. Over the last few years, American big tech, the massive cloud providers and search giants, have been spending hundreds of billions of dollars.
Unprecedented amounts of cash.
Right. They are essentially building the most luxurious, state-of-the-art grocery stores on the planet. They are buying prime real estate, laying down imported marble floors, building elaborate display cases, all under the assumption that they will be able to charge a massive premium for their goods.
And that grocery store is the physical infrastructure of AI, the data centers.
Right, the servers, the cooling systems, everything. Then suddenly, Moonshot AI opens a massive bare-bones warehouse directly across the street. And they're selling the exact same high-quality groceries, but for absolute pennies on the dollar.
Yeah, it's a huge shock to the system.
So if you hold stock in that luxury grocery store, your immediate thought is, wait, did we just waste $100 billion building a premium infrastructure for a product that is rapidly becoming a cheap global commodity?
And that phenomenon right there is what analysts are calling the second DeepSeek shock. It's this deep fear that the immense investments in data centers and high-end processing chips will basically never generate a profitable return.
It's a terrifying thought if you're heavily invested.
It is. However, looking at the broader macroeconomic data from July 2026, assuming this price cut alone caused the whole market crash, is a massive overreaction.
Okay, let me push back there a little bit, because a 20% drop in semiconductors feels very definitive. Why shouldn't we blame Kimi K3 entirely for that?
Because the market was already a powder keg waiting for a spark. Throughout the first half of the year, valuations for tech stocks and semiconductor companies were stretched to historical extremes. I mean, they were priced for absolute perfection.
And when an asset is priced for perfection, even a slight breeze can knock it down.
Exactly. Add to that the broader macroeconomic environment. We had escalating tensions in the Middle East, threatening supply chains, global oil prices were surging, and many institutional investors who had seen massive gains in the AI boom simply decided it was time to lock in their profits.
So K3 was just the catalyst.
Right. K3 was the catalyst that pierced the bubble of invincibility surrounding U.S. AI infrastructure spending. But it was not the sole cause of the sell-off.
Okay, that makes perfect sense for the broader tech market. But let's zoom in specifically on the hardware side.
Sure.
If we go back to the software efficiency of Kimi K3, the mixture of experts routing, the delta attention mechanism saving compute power, my instinct tells me that highly efficient software is a death sentence for hardware manufacturers.
It seems like it would be.
Right. If K3 can do the same job using a fraction of the processing power, why wouldn't total global demand for expensive American computer chips just plummet?
It is a totally intuitive assumption, but the data reveals the exact opposite reality. Highly efficient AI does not reduce hardware demand. It actually accelerates it.
Wait, really?
Yes. Kimi K3, despite its clever architecture, is an absolute hardware hog at scale.
How is that possible if it's only routing prompts to specific experts? Doesn't that save power?
It does, but you have to look at the underlying physics of how these chips process data. To run a 2.8 trillion parameter model, you need an architecture known as high bandwidth memory, or HBM.
HBM, okay.
The limiting factor in AI processing isn't usually how fast the chip can do the math. It's how fast data can be fed into the chip. Normal memory is like a 2-lane road. HBM is like a 100-lane superhighway stacked directly on top of the processor to feed the beast without bottlenecks. K3 requires vast amounts of this highly specialized memory.
So you can't just run this cheaply on older standard servers in someone's basement.
Not at all. To run K3 efficiently for enterprise clients, recent analysis suggests you need clusters of 64 top-tier advanced GPUs working in perfect synchronization. And they have to be connected by ultra-fast communication links, housed in server racks utilizing intense liquid cooling systems.
Okay, so the physical requirements are still massive. But doesn't the cheap price of the software mean companies will ultimately spend less money on the hardware to run it?
And that brings us to one of the most vital economic principles for tech investors to understand today, which is the Jevons paradox.
Okay, I love this concept. Break it down for us.
Back in the 19th century, an economist named William Stanley Jevons was studying coal consumption in England. Engineers had just invented much more efficient steam engines that required significantly less coal to do the same amount of work.
Right. The logical assumption being that total coal mining would drop, since everyone needed less of it to run a machine.
But the exact opposite occurred. Because steam power became cheaper and much more efficient, businesses started using it for absolutely everything. Entirely new industries expanded, new machines were invented, and total overall coal consumption skyrocketed.
Wow.
Yeah. The paradox dictates that when a resource becomes cheaper and more efficient, usage scales up so dramatically that total demand for the underlying fuel actually increases.
We see this in the modern economy all the time, too. I mean, think about airline tickets. If a commercial airline suddenly figures out how to drop ticket prices by 80%, they don't respond by grounding half their fleet.
Right, no way.
Suddenly, millions of people who could never afford to fly are booking weekend trips. To handle that massive surge in demand, the airline actually has to go to Boeing or Airbus and order significantly more airplanes.
And that is exactly what happens with artificial intelligence. When an AI model costs premium prices, a corporation only uses it for their most high-value, critical tasks like drafting complex legal contracts or analyzing major financial mergers.
Because they can't afford to waste it on the small stuff.
Right. But when a model like K3 drives the cost down to pennies...
You stop treating it like a luxury and you start treating it like an everyday utility.
Precisely. You stop using basic chatbots and start deploying autonomous AI agents.
And what's the difference there exactly?
Well, a chatbot waits for a human to type a prompt, which is incredibly slow. An AI agent is given a broad goal and works autonomously in the background. It will write thousands of lines of code, test that code, find its own errors, rewrite the code, and run it again and again.
Oh, I see.
This iterative loop burns through millions of tokens per minute.
So a cheaper model means widespread adoption of autonomous agents, which means token consumption goes exponential, which means data centers need exponentially more semiconductor chips, cooling systems, and electricity just to keep up.
The hardware demand is insatiable. The Jevons paradox basically protects the physical infrastructure companies.
Okay, so if I'm looking at my portfolio,
Yeah.
the companies designing the chips and building the data centers have a very solid fundamental thesis.
They do.
But let's look at the American software giants, the massive cloud providers, and the companies building the proprietary U.S. models. Are they safe? Because if the hardware is fine, somebody has to be taking the hit from this cheap Chinese software.
Oh, they're the ones squarely in the crosshairs. The threat to U.S. big tech isn't that nobody will use their AI. The threat is a catastrophic squeeze on their profit margins, specifically impacting a metric called return on invested capital, or ROIC.
Let's break down ROIC for the beginner. It's essentially a measure of efficiency, right? If a tech giant spends $50 billion building out these massive liquid-cooled data centers, ROIC measures how much actual cash profit comes back into their pockets from that specific investment.
Exactly. And over the past few years, U.S. big tech has enjoyed massive pricing power. If a global enterprise wanted enterprise-grade AI, they had to pay top dollar.
They had no other choice.
Right. But let's introduce Kimi K3 into the corporate ecosystem. If you are a multinational bank, you realize you can use the cheap Chinese model to handle 80% of your daily routine tasks, like sorting data, summarizing basic emails, and running your standard customer service bots.
And then what?
You then reserve the expensive, premium U.S. models strictly for the hardest 20% of your high-level analytics.
Oh, wow. So the volume for the U.S. companies completely collapses. And to win back that 80% of routine traffic, American companies have no choice but to slash their own prices to match the Chinese warehouse.
And the moment they slash their prices, their return on invested capital plummets. They're still paying the massive electricity bills, and they're still buying the expensive hardware, but the revenue they generate from it shrinks drastically. The era of the blank check for U.S. software is severely threatened.
And, this margin squeeze doesn't happen in a vacuum. We cannot discuss Kimi K3 without addressing the massive geopolitical chessboard it sits on.
Absolutely.
Currently, under U.S. President Trump, the United States has heavily focused its AI strategy on physical containment. The policy revolves around restricting access to advanced semiconductor chips, maintaining closed and proprietary software models, and utilizing really strict export controls.
Right. The goal is to secure American tech supremacy by controlling the physical supply chain.
It is a strategy of building a very tall, very secure wall. But you have to look at how China is countering that strategy. At the recent World Artificial Intelligence Conference, Chinese President Xi Jinping made a major policy address. He stated clearly that artificial intelligence should not be monopolized by a few nations.
Now, that sounds like standard diplomatic rhetoric, but according to the data, he immediately backed it up with infrastructure commitments.
How so?
While offering 5,000 AI training opportunities and technical support specifically targeted at developing nations, often referred to as the Global South.
So this is where the mechanics of an open-weight model like Kimi K3 become a geopolitical weapon. The United States can control where physical chips are shipped, but an open-weight software model can be downloaded and run locally by anyone.
Right. China is essentially offering highly capable, incredibly cheap software to countries in South America, Africa, and Southeast Asia.
So instead of a country like, say, Brazil or Nigeria having to pay premium prices to route their government data through American servers, they can just integrate the Chinese model directly into their own national telecom networks, their banking apps, and their state infrastructure.
Exactly. It completely bypasses the physical hardware choke points the U.S. has set up. China isn't just trying to win a coding competition here. They are executing a calculated diplomatic strategy to make their AI the underlying operating system for the entire developing world.
Why? So if you are an investor looking at the long game, you shouldn't just be tracking which company has the smartest AI in the laboratory setting. You need to be analyzing who can distribute their technology the cheapest, who can integrate it seamlessly into global infrastructure, and who can successfully navigate or bypass these massive political roadblocks.
That is the defining investment thesis of the next decade. The ultimate winner is rarely the absolute smartest technology. It is the technology that becomes the unavoidable, indispensable global standard.
We have covered a tremendous amount of ground today. Let's distill the key takeaways from the recent analysis for you, the listener. First, Kimi K3 is an undeniable wake-up call. It proves that the technology gap between the United States and China is rapidly closing. The days of U.S. software giants charging whatever they want are over, and they are facing a serious squeeze on their profit margins.
Secondly, and perhaps most importantly for your portfolio, the initial market panic that cheaper software would destroy hardware demand is economically backward.
Because of the Jevons paradox.
Right. Cheaper AI means autonomous agents become the norm. That drives exponential token consumption, which guarantees a massive ongoing demand for advanced data centers, cooling infrastructure, and semiconductor chips.
So the infrastructure trade remains highly resilient, even if the software trade gets highly competitive.
Which leaves us with one final provocative thought regarding the future of your investments. We often try to find the one company that will win AI. But let's look at the history of technology. When the electrical grid was first built, the companies generating the electricity were valuable, sure, but the true multi-trillion-dollar wealth wasn't created by the power plants.
Who was it created by?
The appliance makers. Once electricity became a cheap, invisible commodity in every home, the visionaries who invented the washing machine, the modern elevator, the electric assembly line, they were the ones who changed the world and captured the massive wealth.
That's a great point.
If AI intelligence is rapidly becoming as cheap and accessible as electricity, the most valuable companies of tomorrow likely haven't even been founded yet. They are just waiting for intelligence to become cheap enough to plug their new ideas into.
The intelligence appliance. That completely changes how I'm going to look at startups going forward. Don't forget to subscribe and hit that like button.